Good afternoon, folks. Well, buckle up, buckle up. Today we are going common sense. Pretend, sit down, calm down, settle down. Come on. Pretend, if you can, you've never heard about your science. Never, right? I was going to say, let's just pretend that you were starting from scratch with the speed of light. You are starting from scratch with the speed of light. So, I used to say that the diameter, that the power and the size of the light source is what determines how far that light radiates, okay? And people used to think, for some reason, that I was saying the bigger and more powerful the light source, the faster the light would get. It went on for quite some time. I used to say, what determines the distance that light radiates at absolute speed is the power and the size, the diameter of the light source. How does that make it go any faster, mate? I'm not saying that. I'm saying that's what determines how far, not how fast. Yeah, but what has that? Right? So it went on for enough time that I was like, people are not reading what is being written, okay? Now, when people used to click onto it, go, okay, so, but light travels forever. So what difference would it make? What difference would it make? 5 centimeter diameter bulb, 5 centimeter diameter mirror. So we've got enough sun. I think we might get away with it. What difference is there? People say. A light is light, isn't it? Light is light. Light is light. It's on now. Speed of clouds. They're both 5 centimeters in diameter, aren't they? So, why is it this one will bounce its light 50 k's, easy, boom, no delay. This one, 50 kilometers, it's not going to happen, is it? You know it's not going to happen. So what is this light travels forever thing? This will be seen at 5, 6, 7. Then what? People have this thing, like all the photons, like, all right, see you, mate, and they'll split up into little. No. Common sense. Difference between these two? You look? You look? So people go. So what's the difference between that and that big mirror? Which is going to radiate its light the furthest? It's not even a... It's one of those things, isn't it? But there'll be people still Remember, this is common sense today. So, this, a 10 to 12 centimetre diameter mirror will bounce the sun's light 125 plus miles. 5, 40, 50 miles easily. And it's not a case of it's flash. There's this thing. It's this thing called a photon that you believe has to come to your eyes. When I'm looking up at the sun, okay, dong, I open my eyes. There is nothing in between my eyes and the sun. The sun is big, it's bright, it's obviously exactly where it seems to be in the sky, okay? What is it? I think I might have been, this was where Simon Dan picked me up, and I said, explain to me the science that says I wouldn't see my own star if it turned on for 8 minutes and 20 seconds if it were off. Explain to me the science that says if I was looking up at the sun and it turned on, even if I was looking in its direction, that I would not see it right in the sky exactly where it was. My eyes are what? That I can only see, like everything is, I'm seeing the outside world, for crying out loud. You don't wait for photons to come here. I see things where they are. A light source, stars in the night sky. I see them because my eyes can see stuff at a distance. It's not just a couple of eyes in a head on a stick waiting for information. I can see stuff. I'm pretty sure we're built the same, okay? Now, this notion that looking at the sun, if it turned off, it turned on, you're looking up at it, but you can't see it for 8 minutes and 20 seconds because you've got to wait for a wall of invisible massless packets of invisible massless photons. And you wouldn't see because they have to arrive. You don't think you'd see the sun exactly where it is when it lit up because your eyes can see stuff at a distance. You need to think about that one as well because it is key, right? I don't think I focus on it enough, right? It's not just about light being absolute. It's about you being able to go bang and look at one of the furthest stars in the night sky in that direction and then go bang. And the same again in the other direction, 180 degrees out. You're not waiting for photons to come to you. You're seeing stuff where it is, right? Slam dunk. Photons, cones and rods and retina damage. It's these things, right? So, if there was a race between eyesight and light, it would always be a dead heat. Because everywhere that you looked, if there is something there to see because there is light, you see it, you're seeing it in real time. There's no delay. It's illogical. It's mind-numbingly logical. It really is. And during a solar eclipse, which clearly proves this fact, it simply has to be absolute light because as seen from the sweet spot on planet Earth, the moon right there is directly in front of the sun. Whether we are on a flat Earth or a round Earth, I'm glad I remembered. Like I always say, I'm explaining it with a round analogy because it's the one that I know how. And somebody dared me to learn the flat Earth, right? How it works, the system, and explain a solar eclipse using the flat earth analogy. So I obviously have to learn the flat earth. Look, it's the most logical thing we have, okay? Sun and us, to think. I think it would be very easy for somebody to come here with a flat earth system. I think it would be very easy to dismantle it and say, no, that cannot be, in seconds, unless it was true, right? I really do, using logic. The only reason I'm going with the round and the gravity and everything is because it's what I was taught. So I believe it. The tides and the moon, makes the water move, even though it's such a long way away. The moon is 30 Earth diameters away from Earth. It's quite a long way, isn't it? How many moons away? 100 maybe? 80, 90, 100? Something like that. I don't know. But it's some very strange stuff. Listen, so somebody dared me, but I cannot, because it will be too distracting and something might come up. I cannot stop with the speed of light. I promise. Once you've all woken up and you understand that light is absolute, bang, go for the flat earth, right? I just cannot. I took the telescope down a couple of times, no, once, down to the beach, but too windy, and I haven't done it since. I just need to keep banging this out. Okay, 12 minutes. So, we have a diameter, 5 millimeters. Bang! 1 million diameters of itself in how long? That long. 5 centimeters, 5 Ks, 100,000 diameters of itself. A normal 5 centimeter diameter light bulb. Here it is. Bang! Somebody at night time over the river 5 Ks away, they're going to see it at the very same time as me. From here. We're both wired in, he's 5 Ks away, and I go, no, we'll get somebody else to do it, because obviously I could cheat, I'd have the edge. No measurable light delay. Anybody who says there is, try it. Right? Now, we bump up to a diameter of 50 centimeters. Light source. 50 centimeters, right? Half a meter. Boop, diameter. How far, is it going to radiate its light further than the 5 centimeter? We're talking diameters now, okay? Is there any logical reason that you could think of why the 50 centimeter wouldn't radiate its light 100,000 of its diameters, bang, like that, like the 5 centimeter? And we know the 5 centimeter does because we see it at 5K, boom, instantly. So now we have a 50 centimeter diameter light source. That probably, that one would be not best size. Now what are we looking at? Is there any logical reason why it wouldn't radiate 100,000 of its diameters in, bang, a heartbeat? Not really, is there? There isn't. Why would it not? The fact is, it would not matter how far anybody was from that light source, the 50 centimeter diameter one, if we had people 200 kilometers, right? And gets thrown on. Every person on every kilometer is wired into a button. When you see it, people, hit, winner gets $100. goes on, it would be about reflexes. If the guy at the end, the furthest distance from the actual light source itself, had the quickest reflexes, he would click the button first. It would have there would not be a pattern from closest to until furthest from. There wouldn't be. Try it. It wouldn't be. Same as the mirror. Now the sun's come out. That mirror, that big square one, right? That has got to be easy 1,000 miles. There is not going, I know what you're seeing, kind of a thing. That isn't a measurable quantity. You have somebody, say 1,000 miles, has to be. 10 centimeters, 125, that's times 10. 1,000 miles. Bang. Again, when that mirror got into position, and you had 1,000 people in a line, all focusing on the point where they knew where the mirror was going to be, and somebody, boom, got it into position with that flash, you are not going to measure a delay between the first person and the person at 1,000 miles, because your eyes also see it. It's not even a case of you meet it halfway. It's a case of if there is a light source in the sky, in the night sky, and it is within your range, you'll see it exactly where it is. There's no delay. It's illogical to think you're looking at delayed light any time, because you never see the light source itself. It's insane. It would always be 8 minutes or whatever ahead of where you could see. You can't see the sun in the sky at the same time as be standing on photons that have been travelling for 8 minutes and 20 seconds. This stuff is so illogical. But remember, common sense afternoon here. Now, what's that? 50 Ks, isn't it? 50 centimetres. Alexa, what's 100,000 times 50 centimetres?
100 times 100,000 times 50 centimetres is 5,000 kilometres.
Alexa, what's 50 centimetres multiplied by 100,000?
50 centimetres times 100,000 is 50 kilometres.
50, is that what I said? I think 50. I did say 50, don't say 5, did I? No, 50. So, a 50 centimetre round light source, right? 50 Ks. Easy, isn't it? Fine. 50 Ks. And how long does sun get 50 Ks? And you turn this half-metre diameter light source on, and you're looking in that direction. Do you think it's going to be some kind of delay? No. So then we go to 5 meters. Right, let's bang out a light source with a diameter of 5 meters. That's going to be, this is what, 2.5? So we're looking at a 3-story bedroom, right? But round. Give or take, okay? 5 meters in diameter. So yeah, 5 5 meters. That's big. Times 100,000 of its diameters. What's that? 5 meters times 100,000 should be 500, I would say. Yeah, it must be. 500 kilometers. Alexa, what's 5 meters multiplied by 100,000, please?
5 meters times 100,000 is 500 kilometers.
Look, I just wanted to make sure, okay? I knew it was, but I thought, well, I've gone this far, I just wasn't sure. So, yes, 500 Ks. A light source with a diameter of a 3-story building, right? 500 kilometers. It's nothing. You see the International Space Station going over, was it 400 Ks up there? Don't people see it at night with the little lights and stuff? So, yeah, not a problem at all. So what if we go to 50 meters? 50 meters, then it's 5,000, isn't it? 5,000 kilometers. 5,000 kilometers, that's just under half of Earth's diameter, 3,742, 5 Ks. So just under 500 meter diameter, 50 meter diameter. That's a monster, isn't it? That's going to be, what, how many stories are we looking at? 30? 30, not a skyscraper, but round. Right? How far do you think that is going to radiate its light? Okay, so we've got 5,000 Ks. Something that size, look, you've got to be talking, I don't know, easily 10, 20,000, isn't it? It's common sense, remember? Common sense. All we've been doing is doubling the distance. No, staying proportionally the same. 100,000 diameters, 100,000 diameters. Bang! Like that. We keep going and we finally get to a star that has a diameter of 299,792 kilometers. Now, is that going to radiate its light like all of the other stuff? 100,000 of its diameters, bang, in a heartbeat. Is it or is it not? This one, it won't, because it will take 1 second to radiate its light the distance of its diameter, because it has a diameter of the speed of light, 299,792 kilometers. So all of a sudden, we've gone from these things here that are just going bing, look at me, to a star with a diameter of 299 speed of light, and it's taking a second. What happened? Getting bigger, more powerful, but the speed of light. So when the science comes in, holy smokes, illogical. And then, oh, I've got it down there, haven't I? I came prepared. Then we get to another light source. It has a diameter of 1,390,000 kilometers. The sun. Now, if 100,000 diameters, bang, as soon as it went on, we would have been looking good along the common sense boulevard there, along with logic and stuff. But no, the bigger it gets, the slower it radiates its light in relation to a smaller version of itself, because it now takes 4.6 seconds for it to radiate its light, one diameter of itself. Now, common sense, it's screaming the house down, but nobody's listening. A star, a light source, taking 4.6 seconds to radiate its own light the distance of its own diameter. It's an insult to all of humanity's intelligence. Doesn't matter how many people they tell you, it's illogical. Highly illogical. Surely science must contradict and kick its own arse somewhere along that route, because to get to something with a diameter of 200, like the speed of light in kilometers, and all of a sudden it now takes a second. So when we were down here, everything is like boom, 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 but then we get burned, because the bigger you get, it doesn't mean anything. No more power. Power, it doesn't mean anything to be bigger, does it? Really? It just doesn't. A light bulb or UY Scooty. What's the difference? All light travels forever at the same time. Nothing special happening there. Oh, I'm a really big star. Yeah, and, mate? The bigger, more powerful a star is, bang, the further it will radiate its light at absolute speed. You will never, ever see a light source that you cannot see from the onset. Like, turn it on, doop. Anybody who's looking in that direction will see it, doop. Right after you hear, doop. If they're going to see it, that's when they see it. If they're too far away from doop, whatever doop is turning on, they won't ever see it, because it's too far away. It can't be a light day away from somewhere. It's, you either see it or you don't. Absolute light, absolute eyesight. There's no waiting around for Mickey Mouse photons to get on the shuttle. I'm telling you, there's not. So that is the common sense. And then, of course, we have UY Scooty at approximately 2.377 billion kilometers, and it takes poor old UY Scooty 2 hours and 12 minutes to radiate its own light, the distance of its own diameter, because it's 2.37 billion kilometers in diameter. Right? 2.377 billion kilometers in look. It's what they tell us, isn't it? Black holes, gravitational waves. Where's this 299,792 coming from? I don't see it anywhere. It doesn't tie in with common sense. It doesn't tie in with the solar eclipses that we see. It wouldn't have tied in with Roma's eclipse, Jupiter and Io, because there is no light delay down here. Look, the whole thing is just plain stupid, right? So that's a look at it with common sense. It's about common sense. The solar eclipse is about common sense. There's no light delay. How can there be a light delay? You can't have a light delay during a solar eclipse, because planet Earth, in 8 minutes and 20 seconds, turns by 2.08 degrees. And as you can see during the solar eclipse, what's happening here is laser precise, isn't it? You can see Baily's beads. You can see the moon. Terrain, Baily's beads it's called, just as it's coming into the eclipse position in real time. So what's happening there? You're looking at the moon, and you can see the sun behind the moon, and photons. Listen, it's all horseradish. That is going to be it for the common sense part of today. I can't blow anybody's mind with any more common sense, because it could get scary. Solar eclipse, folks, speed of light, it doesn't matter how you look at it. It is about common sense. Common sense comes way, way before the absurdity of Rome in 1667, and way before the absurdity of Bradley in 1728, and of Fizeau in 1849. Solar eclipses have been happening since forever, and they have been happening with absolute light. It's obvious, right? It's obvious. Everywhere you look, there's just no sign of any light delay. Everywhere you look, it's a sign of absolute light, because everything's casting a shadow. Everything out there is casting a shadow, right? It has the sun directly behind it. If the sun were 8 minutes and 20 seconds away from where it really is in the sky, why would I see it? I wouldn't ever see it. I'd see the Mickey Mouse photons coming down like they say they are, but I wouldn't see any light source behind it because it's 8 minutes and 20 seconds away. You cannot have the cake, eat the cake, come back for seconds. No more still for you. It's illogical. Everywhere you tread on this one, it's illogical. So, that'll be it for now. Have I forgotten anything important? Oh yeah, that light is absolute. That it's as important as it is obvious. So obvious. So important. But we'll keep hearing the arguments against, but every argument that does come against it is devoid of all common sense, rational thought, and logic. Because there is no logical explanation for how a solar eclipse plays out Mickey Mouse photons. Massless, invisible packets of massless, invisible photons. So not only are they massless and invisible, they're coming down in packets that are massless and invisible. Look at everything that they do. No. Eyesight is absolute. There is no delay. You're looking up at the night sky, right? And there is a supernova, a star. I'm calling one towards the end of April, just for fun. If you see something light up in the night sky, the reason you are seeing it light up is because it is powerful enough for your eyes to see. Not just it get to you, but you see it where it is, waiting for photons. Guys, seriously, think about it. How can there be an invisible barrier if the sun is off now out there in the sky and I'm looking up at it and it's off? I know roughly where it is because it's my sun, and it turns on. What is going to stop my eyes from seeing the light source where it is? What's this? I have to wait for photons to hit retinas? Guys, this is why they're one step ahead of you. I'm with them. I know light's absolute. There's no delay. Get back on board with common sense, I'm telling you. Chop, chop. Quick, quick. Pushing it for time as it is. Can't believe they've allowed me to stay here so long doing this. Yes, I do. Because there is so much other stuff out there, and people do not know how to differentiate between what is real and what isn't real. It's a nightmare. 30-second reels and this and that and the other. And some of the stuff, you can tell the YouTube stuff. Guy on last week talking about light and something. 5 million views. It's all horseradish because of the solar eclipse. All of it. simple stuff. There has never been a time so important to be able to differentiate between what's real and what isn't, as it is now. It is so important. It's not about trusting other people. It's about people knowing how to think, to work these things out. They're not complicated. It's common sense, logic. You don't need scientists to tell you all the crap, because you already know, using the very basics, that it isn't possible. It's absolute light. They're claiming knowledge that cannot be known. And after that, absurdity central. Senores y senores. All right, folks, happy Sunday, and I hope you enjoyed a bit of common sense. All right, later, folks.